So here for pushing the lawn roller, so the lawn roller, the side view of the lawn roller is like this. So here the total weight of the lawn roller is applied in the downward direction. The total weight of the lawn roller is applied in the downward direction, and the whatever the lower surface is there, that lower surface is acts in the equal and opposite normal reaction force in a upward direction. So and this is about pushing, right? So here this is the pushing direction. So pushing force. So how we push the roller with its axle? So like this, right? So here we can push the roller in this direction. So that's why this pulling force, net pulling force, is divided into horizontal component and vertical component. So horizontal component is F cos theta, vertical component is F sin theta. But the net pulling force is acts in downward direction, in this direction. So that's why the vertical component is acts in downward direction here. So the F sin theta is acts in downward direction here. Okay. So the whenever the pulling force is acting on the roller, so the lawn roller moves in this direction right here. So this is the rolling friction. So rolling friction is applied in the direction opposite to the applied force here, applied force. So now according to this diagram, so we can write this equation. So normal reaction force in upward direction and equal and opposite mg and f sin theta is there. So according to this diagram, so we can write n equal to mg plus f sin theta, mg plus f sin theta. The rolling friction Fr equal to mu r into n. Here mu r is the coefficient of rolling friction and n is the normal reaction force. We knew that relation. Okay. So here, so Fr equal to, so in place of n we can substitute the above equation. So therefore Fr equal to mu r into mg plus mu r into f sin theta. So now the net pushing force. So F equal to, here the net pushing force. So here only the horizontal component is applied to the lawn roller to move it in forward direction. So here F cos theta is applied in horizontal direction. So but the counter force, rolling friction force, is applied in backward direction. So that's why the net pulling force. So therefore what we can do that here, so F cos theta minus Fr. So we can subtract the rolling friction from F cos theta. Why? Because this is the actual force applied on the roller F cos theta, but the counter force Fr is acting in opposite direction. That's why we can subtract Fr from F cos theta. Then we get net pushing force. So net pushing force F equal to F cos theta minus Fr. So now in place of Fr, we can substitute this equation. So F cos theta minus Fr. So in place of Fr we can substitute this equation. Then finally we get this equation and we can put this equation as equation number 1. So now we will discuss about the pulling the lawn roller. So here the lawn roller, okay, so the total weight is acting in downward direction, the weight is mg. So and the lower surface is applied equal and opposite normal reaction force is applied in the opposite direction. Okay. So and how we pull the lawn roller? So the axle is lift like this and we can pull it. Okay. So that's why here the pulling force is in this direction, in upward direction, pulling force. But here the pushing force is in downward direction. So here the pulling force is in upward direction. This resultant force will be divided into two components. That's one is the horizontal component F cos theta, another one is the vertical component F sin theta. So here the pulling force is acts in the upward direction. So that's why the vertical component F sin theta is also acting in the upward direction. So towards the normal reaction force F sin theta is applied. But here in case of pushing, so we can apply the net pulling force in downward direction. So that's why the vertical component is acts in downward direction. But here we can apply the pulling force in upward direction. So the F sin theta vertical component is also applied in the upward direction. So and the roller is moving in this direction. So the counter force rolling friction is acting in the opposite to the F cos theta here. Okay. So now according to this diagram, so what we can write that? So here n and F sin theta both are in upward direction. That's why n plus F sin theta, it is equal and opposite to mg. So that's why we can write n plus F sin theta, it is equal to mg, and n equal to mg minus F sin theta. So here n equal to mg minus F sin theta. So but we know that the rolling friction equal to Fr equal to mu r into n. Mu r is called as the coefficient of rolling friction and n is the normal reaction force. So in place of n we can substitute the normal reaction force equation. So then what we get? So mu r n. So mu r mg minus mu r into F sin theta here. So now the net pulling force F equal to so already, so same like in the previous case, so F cos theta, and the roller is also moves in the direction of F cos theta, but Fr is acting in the opposite direction. So how we get the net pulling force? So we can subtract the Fr from the F cos theta, then the net pulling force is we get. So here net pulling force F equal to F cos theta minus Fr. So in place of Fr we can substitute this equation. So then finally we get F equal to F cos theta minus mu r mg plus mu r F sin theta. So this equation can be taken as equation number 2. So finally the conclusion statement is, so according to the comparing the equations 1 and 2, here equation 1 and equation 2, comparing these two equations, so we concluded that the pulling is easier than the pushing the lawn roller. So pulling the lawn roller is easier than the pushing the lawn roller, or how we can say that pulling the lawn roller is preferred to pushing it. Why? Because pulling is very easier than the pushing. Why? Because according to comparing these equation 1 and equation 2, we concluded that one. So how we can say that? So here you can observe the equation 1 and equation 2. Here F cos theta minus mu r mg. So in the bracket term, so here also I can put a bracket. So here the bracket, so whatever the terms are there in the bracket in both equations are same. Here F cos theta minus mu r mg, here also F cos theta minus mu r mg. So whatever the terms in the brackets are the same in both the equation. So but after the bracket, here for pushing, here we get minus mu r F sin theta, but here we can get plus mu r F sin theta. So that means, so for the net pushing force, here some of the force will be subtracted, some of the force will be deleted from the applied force. So whatever the pushing force is, we can applied, so some of the force is deleted, some of the force is eliminated. Why? Because here minus sign is there, but here the same pulling force is applied on the lawn roller, but here the force is the mu r F sin theta force is adding to this applied force. Mu r F sin theta force is adding to this force, but here the mu r F sin theta force is eliminated, deleted from this force. So that's why here we can need to apply the more force to push the lawn roller, but here some mu r F sin theta force is added to this applied force. So that's why we can easily pull the lawn roller than the pushing it. So this is about pulling the lawn roller is prefer to pushing it. So very important question in your first year laws of motion topic. Okay, is it clear everybody? So this is Kranthi, signing off. Thank you.